Hey there, welcome back to the third devlog in this series. It's Sunday 30th of May and I've had a great weekend so far. I walked around Greenwich with my partner and we took advantage of the eased lockdown measures and took a nice long walk through Greenwich. We had a lovely picnic in Greenwich Park, but you know what? It's time to get down to work, and this week I'm going to create a basic altimeter, which is a gauge that shows the plane's altitude while it's in flight. And once again, Google saves the day. I found lots of tutorials online which shows how a horizontal compass is made with Unity, and I think that's the approach that I'm going to go for. So you can see a set of scales here, which is essentially tiled and repeated. It's a raw image, and when I change the altitude you can see it's scrolling. It's basically an endless image, which is really cool, and that's pretty much what I'm going to go for. So as the altitude increases, we want this to scroll and have numbers on it as it scrolls. That's going to be the juicy stuff which I'll work on in a couple of days. Let me try to explain how I did this. So you can see this is the image, which is the gauge itself. This is the dashboard image, and when I imported it I made sure to set the wrap mode to repeat. What this means is that when you scroll out of bounds, the texture is repeated. So when I go over to the dashboard of the altimeter, you can see the raw image is here and the texture is set to the altimeter image that I just showed you. And when you have a raw image, what that means is you have a UV rect. UV coordinates are really interesting, and I suggest reading and looking into it, but essentially a UV rect has coordinates where the bottom left is 0 0 and the top right is 1 1. So the leftmost coordinate is 0 and the rightmost x coordinate is 1. So when you have an x coordinate of 0.25, what that means is that you've moved a quarter of the width into the right of the image. That gives you access to pretty interesting things, and by making the texture repeated you can see that it allows us to scroll the image, and that's exactly what we need. The theory is a little tricky to understand, but the code is super simple and it's only a couple of lines. So we create a variable called dashboard image UV rect, which is assigned in the awake function the UV rect of the dashboard image. We do this because we don't want to instantiate lots of UV rect objects in the update function, and then in the update function we make sure to update the variable's x coordinate to be the target transform, which is the glider's y position coordinate, which is the glider's height, and then we make sure to assign the actual dashboard image UV rect to be that variable we created. It's Tuesday 2nd of June around 9:45 PM and I'm going to do 1 hour of work before I head to bed. What I'm gonna try and do is add some numbers here so that as the altitude changes, the numbers will scroll with the gauge. Okay, so this is going to be a little tricky. Let me show you. So the issue here is that when I move the altitude number, you can see it doesn't move, the label itself doesn't move as much as the gauge, so it looks kind of weird. It doesn't scroll as fast as the gauge itself. So I need to figure out how much I should scale the movement by. That's going to be a little tricky. Yes! We did it. Let me show you. So we finally got this label to move with the gauge. So when I change the altitude, you can see the label moves. Oh, that took so long. Honestly, I'm so stoked. I was actually running out of ideas, so I'm glad it worked. Let me try to explain how I did this, but please forgive me for my crude drawing skills, but I'm going to start by drawing the phone itself with the player character in it. Next, I'll draw out the Altimeter dashboard. Now we know that in UV space, the width of this texture is 1 UV, and therefore, since there are 4 gaps, each gap is a quarter UV, i.e. 1 divided by 4. Now if we define each gap as being 10 meters, so when the plane moves by a height of 10 meters, then a quarter UV scrolled is 10 meters. In order to determine how much the labels need to move by, we need to know the width of the texture itself. The amount the label needs to move by is defined by wild coordinates, and so is the texture's width. Therefore, the width of each gap is equivalent to the width of a quarter of the texture's width. So when the plane moves 10 meters, we need to scroll the label by a quarter of the texture's width. Anyways, I'm gonna check back in tomorrow. Hey there, it's the following day around 9 PM and it's time to get back to work. I'm going to work on auto-populating the altimeter with the correct altitude, height labels. So I'm looking forward to seeing that done. Positive thinking, right? So far so good. Let me show you. So it's looking pretty good. I'm going to click this play button. What you can see is this 50 then auto-populates to become 5 labels from -20 all the way to 20. But when I scroll the altitude, you can see the labels are static and don't follow the gauge. So it's time to work on making these numbers change and move. So what seems to be a common theme across the videos on this channel is that nothing seems to work on the first go, and this was no exception. So you can just about make out here that the labels aren't moving with the gauge, it stays static, but at least they're appearing. So back to the drawing board, but for attempt number 2, still it doesn't work. You can see nothing moves. Back to the drawing board again, attempt number 3, it seems to be working, it populates in front, but when you scroll backwards, it doesn't populate. So, same story, back to the drawing board again. So I think this was attempt number like 10 or 11 or something like that, I don't remember, but it was the closest to getting it working. You can see that it scrolls in both directions, but the numbers are flickering. So back to the drawing board again. So every attempt after that just got worse and worse. Honestly, sometimes I think that 95% of my time is spent fixing bugs, 4% of my time is procrastinating, and the last 1% is probably actually doing some work. But anyways, I decided to clock off and leave the problem for tomorrow. Hey guys, it's Thursday now around 8 PM. I never got to the bottom of the problem yesterday, but I think I figured out the solution in the shower, so I'm gonna try and implement the solution after dinner. Let me show you what I've got so far. So when I hit play, what you see now is the altimeter looking pretty damn fine, if I must say. So when I scroll the altitude, you can see the numbers populating to the right, which is great. That's exactly what I need, and it's a first step. You can see there's a bit of lag. The labels aren't populating fast enough, so that's something I need to work on. But yeah, going to the left, nothing seems to happen. No labels are populating, so that's what I'm working on now. Checking back in, it's around 11 PM now, and it's pretty much time to call it a night. But I'm pretty happy with what I've got so far. There was a bug where I saw a lot of flickering as the labels jostled for position in the camera's viewport, but quickly fixed that. So this is what I've got now. It looks pretty good, scrolls pretty well, and you can see the labels populating, dynamically populating in the correct positions.
One really annoying thing is that the labels just randomly pop up. It doesn't look very smooth at all, so that's going to be a quick fix. My solution is to basically reduce the width of the game object because it has a image mask component attached to it. So the image mask covers the edges of the altimeter, so it should cover the labels which are popping up outside of the image mask. So it should look smoother, as you can see here. I'm pretty happy with the results, if I'm honest. Next up, I hooked up the altimeter with the plane, so when the plane moves you can see the altimeter changing its value with the plane's altitude. One thing I don't really like here is that you can't really tell, and it's not very obvious, what the current altitude of the plane is, so I'm going to put that in and make the scales look a bit nicer too. What I did was I added a image of a grey arrow. That arrow points to the altimeter to tell you what the reading is. I also added a bit of text which can be controlled via scripting. The script controls the value of the text so that it adjusts it to the altimeter reading. And voila, this is what you have. It looks pretty damn good, I have to say. I also added a bit of text in the speedometer as well, so you can easily tell what the speedometer reading is. And so when the plane moves, you can see the speedometer reading and the altimeter reading very obviously, which is exactly what I needed. And when I get the plane to fall down, you can see the altimeter reading changing very gracefully, and it's very satisfying to watch. So honestly, didn't expect my basic Unity skills to get me this far. So how did I get it to work? I'll show you the code in a bit, but let me explain to you my logic. I'll start by drawing out the gauge with its 4 gaps. When the game loads, it dynamically generates the 5 labels with the correct numbers in the correct positions. When the gauge shifts to the right, and I'll use my hand to demonstrate this by covering the right portion of the gauge, it represents the glider having decreased its altitude. It means that we now have to add a new label to the left of the gauge because there's a new portion of the image that doesn't have a label. The same exercise can be applied to when the gauge is shifted to the left, and I'll use my left hand to demonstrate this. So in effect, what we've done is we've shifted the furthest right label to the furthest left and changed its number. Let me show you my code. Okay, let me try to explain what's going on without trying to bore you. So in the awake function, we start by locating the labeled template, which contains text component where we update the altitude label. Next, we create the altitude labels, which is the linked list of altitude label template transforms that are created in the correct position with the correct numbers. Then in the update function, we first move the gauge itself by the appropriate amount. Then we adjust the altitude label transforms here, which is defined by if the label is shifted out of view, then we reshift it back into view by updating the number. Then we go through each transform in the altitude label transforms and shift it to the correct position on the screen depending on what the text or what the number of the label is. And that's pretty much it. Pretty simple, right? Took a long time to code though. As always, a couple of things to do before I wrap up this devlog. I'm going to push my work to GitHub, which is my chosen version control system so that this work persists safely. And finally, I'm going to drag the basic altimeter in progress card to complete. Very happy with that, very satisfying. So I hope you enjoyed this video. If you liked it, be sure to hit that like button and subscribe to see more content like this. Anyways, keep grinding that leak code and see you in the next one.